yo, what's up, everybody? Welcome back. Today we are working on our debugger, and today's topic is writing a virtual machine to look up source files, I guess. So I'm in the process of writing this debugger, right? We have some program, simple program. He just like prints some stuff in a loop, right? We can run this under our debugger and we can say, hey, could you set some breakpoints at like a couple functions in this program with these like little offsets? And he's good enough at this point to kind of say, in this very specific scenario, we have like hit breakpoints at each iteration of this loop, and we can print out a couple variables of like varying sizes in there, right? So we can like detect that this variable y is a u8 with size 1 and his value is 5. And variable x is an i32 with 4 and his value is 4, right? And he prints out each iteration loop. He's also figured out that like, yes, this is my breakpoint in like address space, but this is within this function. Yeah, and that's where we're at right now. And we have to do this annoying thing right now where we have to specify offsets in a function to where we want a breakpoint, right? Because if you were to print these variables at the very start of the function, then they would just be kind of like garbage values because they haven't been set yet, right? There's a point in the function where you like run the initializer on the variable, and that's when it's valid. And so it would be nice if we could like set the breakpoint like on the beginning of do print loop, and then we could like step a couple times, and then maybe then we would be able to like set like log the variables on some like button press or something. But in order to do that, we have to understand how like the object, like the compiled code relates to the source, right? If I do like an obj dump -d and I go to like do print loop, right? Where is this thing? Like, this is kind of what the computer sees. I guess kind of like this left-hand column is what the computer sees. This right-hand column is like our representation of that, right? And we need to go from like, the breakpoint knows that he's like here. How do we know like what line of code that is, right? And so I was looking at the dwarf spec, and as far as I understand, I could be wrong here, but I found this section line number information, which is kind of tied to a compile unit, right? So imagine like one source file. Kind of. If you have like includes, then like multiple files get like turned into one. But imagine you just had like one file with no includes, that would be a compilation unit. Anything that turns into like a .o file when you're like running GCC or whatever, which I'm sure everybody watching knows like exactly the object formats and stuff that come out, but whatever. And this thing says a source level debugger needs to know how to associate locations and source files with the corresponding machine instruction addresses. Like, oh, that's what I want. That's what I want. We need to do that in the executable or the shared object files used by that object file. Such an association may it possible for the debugger to specify machine instruction addresses in terms of source locations. Exactly what we want. Perfect. This is done by specifying the line number and source file containing the statement. The debugger can also use this information to display locations in terms of the source files into a single step from line to line or statement to statement. Wonderful. Thank you. And you scroll down a little bit and you see like if you wanted to like map every instruction to each line of source file, this would be impractically large. We shrink it with two techniques. First, we delete the matrix from the matrix each row whose file line source column and discriminator is identical with that of the predecessors. Fine. You're like, deleting duplicate info. Great. Any deleted row would never be the beginning of a source statement. Second, we design a byte-coded language for a state machine and store a stream of bytes in the object file instead of the matrix. This language can be much more compact than the matrix. To the line number information, a consumer must run the state to machine to generate the matrix for each compilation unit of interest. The concept of an encoded matrix also leaves room for expansion. The future columns can be added to the matrix, blah, 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 right? And so you're like, okay, state machine, sure. But then you kind of scroll down a little more, and they start talking about, like, here are the registers that you have in your thing. And, like, here are, like, the opcodes somewhere. Let's see if we can find the opcodes. Not these guys, right? Here are the opcodes, and you have like literal, like you're just making like a program for this like super specialized machine. And so our goal for today is try to interpret this thing in some way. We've been using libdwarf so far to kind of work on extracting the low-level dwarf info, because we kind of didn't want to go through this and copy out like, unit length, version, address size, ubyte. We don't want to like copy out these structs and stuff from the thing, but libdwarf, fortunately for most people, unfortunately for us, kind of abstracts away this virtual machine thing and like kind of just gives you the source lines. And I'm like, well, that's no fun, right? Like the point of this is for us to like explore and enjoy funny topics in low-level programming. So it's like, fuck it. We're gonna dodge libdwarf for this one, for the majority of it, and just try to like implement this thing ourselves. So to be clear, if you wanted to do this for real, you wouldn't do what I'm doing, but this is more fun, so let's run it. So the first step is to figure out how this thing works. Getting true type vibes plus hello. Hello. Also, yeah, I remember. I think I saw recently, completely unrelated. Have you guys seen this? LLM in TTF. Have you guys seen this? This thing's so funny. Basically, because like font layout allows you to have like custom scripts in WebAssembly modules, which is already kind of crazy. You can kind of like embed whatever the hell you want in there, and you can like re-render LLM output as like characters in your font, which is very funny, very funny. Anyways, so there is some similarity there. Okay, but we gotta get serious because we're gonna run out of time. There's a cool Tetris font too. Hell yeah. Okay, so the point, I remember the entry point is something like 3.1.1. That's where I found this before. 3.1.1. Right. So the structure of these dwarf files is that like each compilation unit is kind of like stuck, like serialized as like one section. So we can start by looking for our compile unit, and then somewhere in here he says that the compile unit has this thing at statement list, whose value is a section offset to the line number information for this compilation unit. So there's this like line number information segment of the binary. Right, if we look here, we can see that there's like debug line is like one of the sections of our binary. And so I believe that this is saying that each compilation unit will start their program at this thing. And then they say to parse this thing, oh, in the debug line section, go over here. And this is what we were just reading, but he starts talking about how like this thing has like a program header, and we're gonna have to like parse that probably, and then just run the thing, I guess, right? That's probably what's gonna happen. But we first have to like, you know, get the debug line section and read the program header and stuff. So let's kind of start there. Let's start there. Okay, so maybe we will do this in dwarf test. Feels like a good place to do this. And we have right now debug info has a top level iterator that walks over the compilation units. Each compilation unit is like a thing that we can get here. So let's just like kind of like slap a pub on this for now. And we can just start here. So this is going to give us a debug information entry that we can extract attributes from. Dwarf test. So here we can do something like screw whatever we were doing before. We don't need to do that. And let's look at debug info, compilation unit iterator. And what does this come from? He starts with a dwarf debug, which means that we probably need to make one of these things. I'm sure that we make this somewhere in here. Dwarf iterator, here. This is the code we want to copy paste. All right. Where were we? We were in here. Okay. So debug info dwarf debug from path. This needs to be public for now just to make this work. That's fine. Who cares? We won't even bother freeing this thing. Who cares again? And then we are going to look for debug info compilation unit iterator initialized with this debug thing. And then we can do first compilation unit is CUIT next. All right. Or else return error, no compilation unit. This needs to have a path for it, so we're just going to hardcode it for now because we are lazy. So zig out bin debuggy has been our test program for this whole time. And then let's do something with this. So we're going to do first compilation unit dot, I guess there's a lot of stuff on here that is not public that we kind of need to be public. So let's just slap public on this adder thing. Or maybe we kind of try to do all of this in this file and then just call in, because maybe that'll be an easier way to experiment. So we'll call this test experiment. What is this thing called? Line program experiment. We'll just kind of do everything in here, and that will make our lives easier, because then we don't have to deal with all this public private garbo. So here we'll just call debug info public. We need to make it public for this to work. That's true. Debug info what was it? Line program experiment. There we go. Then we can just do everything in there. We should pass in our allocator probably. Certainly he's gonna need it. Certainly he's gonna need it. But for now, we will just ignore it. All right. So we are going to get an attribute from this thing, which actually still isn't working. He says unknown. Oh, because all these things are prefixed with debug info, now that it's supposed to be. All right. And attr takes in a value. So here we saw that that was going to be DWAT statement list, right? Yeah. So this is the statement list offs. I guess this is the attr. And then these things actually have to be freed, which is kind of fun. Statement list attr dinit, I think. This probably has to be tried. And then this has to come from the libdwarf headers. This guy's mad because he needs to return an error, which means that whoever calls this guy needs to write try on him. All right. And then here we can say statement list header as U64 sounds promising. We'll see if this works. Statement list offs. All right. So let's print this thing and just see if this like compiles into something sane. Statement list offs. All right. Stood debug print, I guess. All right. And zig build and run our little dwarf test. Let's see what happens. He doesn't like that. No argument, no error argument or handler available. So he doesn't tell us why, but he says not a U64. So that's coming from here. So what is this thing coming in as? Maybe an adder? It might be an adder. No. We could actually maybe ask for the error. We could do that. So var error is I think it's like a C string. I think. And I think we pass it in like this, and then we can, oops, this is string, like this, I guess we'll call it. And then here we can say stood debug, or stood log error, this thing. Whatever it is. He doesn't like that for some reason. Because dwarf form adder expects a dwarf error. Ah, okay. So there should be a dwarf error. Which then means that, like, does it get passed in like this? This gets passed in like this. My bad, my bad. And then what is a dwarf error? He is defined as some sort of struct. So how do I like pull the string out of this? This is a fucking annoying thing. So let's look over here. Dwarf error. How do I use this thing? Error is using calls. Okay, but then like, how do I like print it? Dwarf error. Dwarf error message. All right. So they probably have some like extra tracking info and stuff in there. So here we say libdwarf error message given our error string. And then that goes kind of like here, I guess. And then we defer, probably it's like libdwarf dealloc error. Here we go. Not that it matters, but you know, might as well. All right, something like that. Something like that. He's actually mad here. I'm just not gonna do this. We're just not gonna clean up because I don't want to. Error. Oh, he's just told me exactly the same thing, just in a fuck. Okay. Okay, we'll just undo all that. That was actually completely useless because we were getting that log printed before anyways, because he was just saying, oh no, this is a different thing. Never mind. We bring it back. We bring it back, baby. All right. Okay, so he's looking for form sec offset, which means that there's probably like a form offs somewhere. This is DW form sec offset, which is not an adder. That is true, but then which one of these like million things is it? Form ref, I think maybe makes sense. I think we tried that. I think we had the same problem the other day. So let's try this. Dwarf offset is a CU long. Okay. So we just kind of run it like this. Self const dwarf attr and const return offs. Simple. Okay, so wherever the fuck we were calling as adder here, we call as ref. Let's try that. Unable to record error. No, not offs. Oh my god, didn't we just fucking say that he is one of those? Oh, maybe it's just this is still not okay. Dwarf global form ref, form flag, form block, form string, form expression location. Jesus. Okay, can we look over? What did he say? He said it was like 0x17, right? Dwarf form sec offset. Here we go. So can we look for a clue in like libdwarf.h? Here we go. What is this talking about? Or dorms, constant form or sec offset. Okay, does anybody tell us when we're allowed to use these things? Not really, huh? Come on, man. Come on. So he says form ref. Oh, compilation unit relative offset of a reference. Sure. Section relative offset of a dwarf attribute. Same as form ref b except. Okay. 8-byte reference. Reference. Attribute has form address. We already tried that one. Debug adder setter. Oh, can we look for a debug line? So annoying. So annoying. Okay, how do we maybe we just look at like the libdwarf source code. It seems like the easiest way to deal with this. Seems like it. What a waste of time though. We were trying to go quick. But it's okay. We will survive. We will survive. So unpack downloads libdwarf. Libdwarf. Please tell me that I can like get access to this thing. So can we look for what is it? Sec off? Something. Okay. Can we look for like who defines like form adder? So here we're gonna look for like oops, wrong one. Dwarf form adder. So he is defined here, and who does the check here? He says someone here complains here probably. Yeah, here we go. So can we look for DW form sec offset in here? Here we go. So this is in internal global form ref b. And here he has a special handler for this, and he returns me back Probably something reasonable here. So can we figure out who calls this guy? So dwarf internal global form ref is probably what we're looking for. Ret offset, but we don't have the offset. We don't have the offset yet because we can't get it. Right? Because this guy doesn't have a handler. Oh, that's so annoying. Okay, so what does he do? Oh, that's such a pain in the butt. I was kind of hoping that this would be like quick, just like yoinkies, yoinkies. But it looks like libdwarf like isn't exposing it in this case. Can we just like patch libdwarf? Can we build this? We might be able to. Hold on. With import nix packages. Is it like this? Packages make shell. And here we're gonna do like native build inputs is equal to packages.libdwarf.native build inputs. I think that's how you do this. And then we have a build inputs comes from there, build inputs. And then we do a nix shell here. Can we at least build it? If we can build it, then we can just we can just patch it. Configure. Auto tools build, I guess. Auto tools build, and then what are we gonna do? I don't know yet. Okay, let's read spec now and try to figure out. So this information, so this is a attribute whose value is a section offset to the line number information of this compilation unit. So how the fuck do attributes work? We can build, which is really good. That means that we are probably in the spot where we can do what we need. So form, it was like something dwarf form.c, I think is where we were. Form adder. So can we just do, so what happens here? He says, if the form is indexed, look in local and tied, blah, blah, blah. We need to look up his attr form, AR attribute form, and somewhere, DW form sec offset is handled here. So we just kind of have to, I guess, just figure out how does like form u data work? Can we just kind of say case DW form sec offset here? And then it would allow us to do as u64, and then maybe we're chilling. Well, we should double check that dwarf allow form u data. That's not used. Dwarf form u data. Dwarf form u data, right? This is the name of the function, which is from here. Calculate info endpoint error, form data internal. This is what we're looking for. I see. So here he needs a special rule. That's so annoying. Okay, how does this work? Read unaligned CK. So, oh, I see. So here it depends on what size, but we think that it should be a U64. And we probably don't think it should be LEB 128 defined, but it's not really clear. So is a section offset to the line number information. This information is placed in a separate object file, blah, blah, blah. But like, does it say how it's encoded? attribute whose value of class line pointer points to the line. Okay. Line pointer specifies location, but like how? This is an offset into this thing. It consists of an offset from the beginning of the debug line section to the first byte of the data, making up the line number list. It is relocatable in the okay. In the 64-bit dwarf format, this is an 8-byte unsigned int value. So we can just put add another case here. And that should be fine. I'm pretty sure. Pretty sure. So if we now just link against this instead, where does our object go? Source maybe? Libdwarf. Where is our shared object? Here's a bunch of auto files. Find .-iname star.so. Hello? Configure prefix equals, maybe we put in like opt. Home streamer opt or something. I don't know, man. I'm just trying to get like something. Make install ls opt lib. Here we go. Okay. Oh, I see. It wasn't a shared object. That's why. So now we need to make our thing link against that, which seems not really obvious what I'm supposed to do here. Can I change like, what is it? Package config path. Env grep package. So if we just make sure that our package config path goes here first, then it's probably fine. So if we do package config libdwarf, we don't have package config. Oh, really? Then how does I don't know how like Zig is finding libraries. Oh, what a fucking derailing. So they do link system library. I think they use package config. I have a suspicion that they do, and they've just bundled it themselves. So let's just do home opt lib package config, and let's just see what happens if we zig build now. arm-r zig cache. And can we do this like verbose or something? Yeah, zig build uses package config. I just don't understand why. Yeah, I just don't understand. That's okay. So I think that if this worked, we should be able to run. We should be able to run our dwarf test thing here. And if we do as u64, this should give us a value that we like. But it's actually really hard to tell. Can we like just take libdwarf out of our environment, and then if it doesn't compile, we can kind of like iterate until it does. Oi, oi, oi. Oi, oi, oi. Yeah, it doesn't like this. Using strategy paths first. So here he's looking at like these things. How's he doing that? He's doing something. Env grep gdb 14.2. My guess is that it's somehow getting through nix ld flags. Nix ld flags equals the exist. We're gonna look for home opt lib first, then look for nix ld flags. I guess he wants -L here, probably. Unable to find. Am I supposed to put a... Oh, it's probably not supposed to be colon separated here. I'm just a fucking dumbass. I'm just used to doing that in environment variables. What if I do this? There we go. Undefined symbol uncompress in libdwarf. So, oi, cat. This libdwarf. So he also needs LZ and ZSTD. I'm missing a piece here of how like Zig usually does this. Can we go like package config or something? So in the compile step, he runs package config if this. And does this, like, if we didn't have package configs installed, is he just fucked? Probably not. Or I guess, like, he just lives with it. Okay, so what if it's not there, he just links it? I see. So probably Nix was handling it before. So if I go back into our thing, and we make sure that our environment does have package config, then it will figure out how to... Hopefully it will figure out how to find libdwarf if we set the package config path appropriately again. Env grep package config. So yeah, there's an existing package config path. And so now we can do this, and then we keep the old package config path, and then hopefully this fucking works now. Really? Do I have to do something that says like do I have to say like dsphera or dwarf test use package root module use... was I looking at the wrong fucking version of Zig? Compile package config. Yeah, I mean, it's still in here. So where is this set? Use package config. This is under module, system lib, or link system library options. Ah, wait, okay. We're getting somewhere. Link system library options. Okay, we're remembering this. So he uses the default options, which says use package config, yes. So then why the fuck is he not using package config? Maybe package config dwarf? Ooh, libdwarf? No, okay. Or maybe we have to do cflags dwarf. Ah, okay. Wait, we're getting somewhere. Libdwarf, maybe? Maybe if we specify libdwarf, then the package config stuff will work? Isn't this a fun little game we're playing? Fun little game. That got better. Except now I bet that where we were saying libdwarf here no longer needs to be prefixed. Because of the way the package config stuff is set up. Okay. And then we're just back to fucking undefined symbol uncompress. And why? Why, man? I just want to fucking run my code, man. It's fun that the verbose build doesn't actually tell me what the command is that Zig's running. Build Okay, package config path is this zig build exe source dwarf test. Just L dwarf. I guess this doesn't use package config. Oh, I'm gonna lose my mind. I'm gonna lose my mind. I'm gonna lose my mind. Okay. So what is... I mean, maybe we just have to manually specify fucking link system library Z and ZSTD or something. Was that what it's called? I can't remember. LD flags, libdwarf. Help. How do I get the libs? Yeah, so he's just not saying that, which is annoying. How do I mean, it's definitely, we saw that there were, he wanted libz and stuff in there, right? We saw that in work, opt. God, I'm gonna lose my mind, man. Yeah, Z and ZSTD. I don't know what those are, but I guess we can try to link them and see what happens. No ZSTD, right? That makes sense. NixOS package search. God damn it. ZSTD. What's ZSTD? Okay. And libz. Yep. Okay. ZSTD libz. Please, please. All I want is to be able to patch my fucking library because it's not doing what I want it to do. It's all I want, man. We're gonna make it though. We're gonna get there. Still undefined symbol? But in our build, oh, we need it on both of these probably. Wait. I think we're there. Maybe this is the one. Maybe this is the one. Oh, perfect. Okay, so now we're just getting a seg fault, which is super cool. It built, but it's just not fucking working. So pretty fucking cool. In fact, it's just breaking like almost immediately. I guess it's possible that the libdwarf version that we were using 0.9.2. So maybe it makes sense for us, just for compatibility's sake, to patch 0.9.2 instead, because I don't want to deal with also trying to hit upgrade bugs at the same time. So how do you do this? You go like archive, you go libdwarf code archive. Fuck, I can't remember. Where is plus 16 releases? Oh, here we go. 0.9.2. Hit me, baby. All right. A unpack 0 libdwarf 9 2. We're gonna assume that we need to make the same patch here, which was in form. It was in form dwarf form.c. It was udata here somewhere. Was it here? Dwarf form udata internal. Yeah. And it was this. We added a case dw form sec offset. Please just let it be over. Configure prefix equals opt. Please let this be it. Make install And we look at opt_lib, and we should be chilling. Okay. 50th time's the charm. 50th time's the charm. This is the one. This is the one. Oh, let's go, baby. I will say that I'm not really convinced that's the right number. But at the very least, it did what we wanted it to do. So can we do this as like a bitcast this to an I64 or something? I assume this is just wrong, to be honest. I assume that our patch is incorrect. Yeah, this is just a big ass, broken ass number. Okay, so let's look at the spec again. This is an offset into the debug line or debug line duo section. DW form sec offset. It consists of an offset from the beginning of the debug line section to the first byte of data, making up the line number list for the compilation unit. It is relocatable in a relocatable object file and relocated in an executable or shared object file, blah, 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 blah. In the 32-bit DWARF format, this offset is 4-byte unsigned value. In the 64-bit DWARF value, it is an 8-bit byte unsigned value, 7.4. There are two closely related. All values that represent lengths of DWARF sections and offsets relative to the beginning of DWARF sections are represented using 4 bytes. Of the 64, blah, blah, blah. A special convention applies to initial length fields, except, right, so this is the initial length field shit. Ooh. Section offset and section length fields occur in the headers of DWARF sections are listed in the following. In the 32-bit, they're 4, in 64-bit, they're 8 byte. Right, so like, what's the fucking problem? Am I fucking stupid? 30 blah blah. Feels like should have worked. Unless it's like, can we like print the hexadecimal of this? And just like see, he doesn't like that. Probably because we have a bitcast in here that we don't need. I mean, that looks, there's a pieces of a number in here that might make sense. I mean, we didn't really look very closely at our patch. So DWARF 64-bit size, read unaligned CK. This is probably, read unaligned CK, I assume, does something like read into this data value, this ret value, read into this ret value, this type. I don't know what data is here. Data must be where we're reading from. And then 64-bit size, and then make sure that we're like before the section end. So that seems like reasonable to me. It's possible that we're in the 32-bit mode. You know, we don't have to be too scientific here. We can just run it and see. Oh, we have to tell this that we changed, so we'll just modify the file quickly so that Zig build is forced to rebuild it, but even then, no dice, huh? Confusing. I'm just gonna double check that if I delete this completely. Make J9, make install. I'm assuming that this should crash now if everything is done right. arm-r zig cache. Zig build. This should crash. No, he doesn't. So what the fuck is going on here? Something's wrong. Something's wrong indeed. Give me a sec. Yeah, this shouldn't work. Right? Am I stupid? we knew that this didn't work a second ago when we used the. I guess we never tested unpatched in this version that we built, but it shouldn't work. Shouldn't work. So something's being cached that I don't expect. We're just gonna like go nuclear here and remove the whole zig cache because there's just something's not right. Give it a sec, give it a sec. Weird. I don't understand. This should not work. Can we force this to build shared? Is that possible? That will reduce some of the confusion. Yeah, let's just do this. Configure prefix equals home opt. Enable shared equals yes. Enable static equals no. Okay. arm-r opt make -j9 make install. And then here we arm-r zig cache make or build. Ah, dude, build systems get me all the time. Can we LDD this thing? Dude, I'm so lost. Oh, this enable share just did nothing? Okay, that's cool. That's super cool. Make clean. Configure? Like, am I stupid? Enable shared, yes. Enable static, no. Did we fuck up those flags? Shared, yes. Static, no. Make -j9. Find .-i name star.so. Okay. Okay. I guess we don't question it. Libdwarf A. Okay. Please. Let's see. Hopefully this time we see an LDD on this thing that says that he needs libdwarf. Here we go. That's a good sign. And then now what the fuck is going on here where it's not broken, right? This was broken when we used the built-in library. Can we, okay. Let's get crazy. We just start from scratch. Configure again. I hate build systems. HXL, thanks for the prime. All right, let's make sure that we do this again. And we run this again. There, okay. This is what I expected. This is what we should see. Right? Now, we go back. And we go to form dwarf form C. And we go to wherever the fuck it was parsing udata. Dwarf form udata internal. This is where we made the change. We make -j9 and make install. He changes something. I hope incremental builds on this thing work. Okay, there we go. He gets 0. We put him on data 8. Make -j9 and make install. We try again. We get big number again. Okay, not great, but at least we now are seeing like consistency. Now the question is so the offset, it could be 0. It could be 0. It could be the first byte in the thing. That wouldn't be insane. So how do we know if we are in line pointer is an offset into the debug line or debug line DWARF section. It consists of an offset from the beginning of the debug line section to the first byte of the data, making up a line number list for the compilation unit. It is relocatable in a relocatable file in the 32-bit DWARF format. This is a 4-byte unsigned value. In the 64-bit DWARF format, this is an 8-byte unsigned value. It seems like we're not doing anything wrong there. It seems like this should be the exact same thing, unless we are confused. Classes and forms. Okay. Oh, wait. This is where we were just now. Okay. Can we look for, like, form encodings? UData constant. So constant is 1, 2, 4 byte or 8 or 16 bytes of uninterpreted data. Or data encoded in variable length format known as LEB128. Okay. So constant, the consumer must use context to know how to interpret the bits. Sure. And then line pointer is, you know, the fact that this says it consists of makes me a little confused. C 7.4. Section offset and section fields. Okay, what the fuck is going on here? So here they say in a 64-bit value DWARF format is an 8-byte unsigned value. I'm assuming that this number is just way too big. Maybe that's like a bad assumption. Can we do like what is this? Oh my god. Like that feels like way too big. Yeah, it's not 301T, right? Kilobytes, megabytes, gigabytes, terabytes? No fucking way. There's no fucking way it's 301 terabytes offset. What am I missing? What am I missing? Okay. Why does he think that we should see section 7.4? Oh, because this tells us 32 and 64-bit DWARF programs. I see. So, section offset and section fields that occur in headers of DWARF sections, blah, blah, blah. What about, like, in the body of these things, blah, blah, blah. A DWARF consumer supports 64-bit must support executables in which the same compilation uses the 32-bit formats and others use, whoa, some compilation units use 32. Oh, we're using 64 everywhere though. I'm almost positive of that. Yeah, I mean, this is fucked. Okay, in the 32-bit format, an initial length field. We're not looking at an initial length field. Section offset and section length fields that occur in headers of DWARF sections are listed following. In the 32-bit, they are 4-byte unsigned integer values. In the 64-bit format, they are 8-byte unsigned integer values. There is nothing special there. We are just supposed to get an 8-byte value. Oh, I'm so annoyed. I'm so annoyed. We were supposed to do something fun today, and instead we're just, like, slamming our heads into this thing. Okay, can we look at maybe what they do again? What was it? It's like form dwarf form.c. Oh, it was already foreground. It was already backgrounded. Can we look for other uses of this thing? Okay, a global offset cannot be returned by this interface. Form ref adder is considered an incorrect form for this call because blah blah blah. is a global offset in the debug info section. For the same reason, these are not returned for this function. Okay, what is this function? Global form ref, give an attribute and an offset. So what's bothering me is that we can't get this offset value because it won't let us. So where does, oh, that's the output. Oh, I'm just an idiot. I shouldn't have patched anything. I just misread the API a while ago and we just went down this rabbit hole for nothing. Okay, hold on. Hold on. We were just supposed to dwarf atter. We were just supposed to say as global offset. I'm just an idiot. Let's try that. As global offs. So this was okay. Can we kind of just undo everything we did here? Let's use the original again. Next shell. I wish I had just read the docs a little bit better an hour ago. But I think that this is just, sometimes you just have to be okay with the fact that this is part of the process. Hopefully. So now, oh. Oops, we still do need Z and ZSTD, I guess. I don't really understand why that worked before and not now. Probably because we installed package config and now it's using package config and trying to link things that don't exist. Oh my god, this needs to be libz. I'm gonna lose my mind. This is the one though. This is it. We're almost there. For sure. Do we build again? We build again. We're fucking in it. So here we want as global offs, and then as global offs was supposed to use dwarf form global form ref b, and this is just like this. He return offset is info. Is a C int, I assume. Okay. Zig build and run dwarf test. Okay. Okay, we got there. I mean, whether or not this is correct is hard to tell. He's writing 0, 0, but we can do try CUIT next and see if we get a non-zero value for the second compilation unit. We do, okay. So it just turns out that the value was 0 this whole time. This whole thing was almost a complete waste of time. That's super cool, love that, but we fucking finally got there. So we actually didn't have to patch libdwarf at all. We just had to read the API a little better. Okay, next piece of info here is we need to import elf, which we have, and we should get the elf metadata given our allocator to the path. So we're gonna call its path here. And we are trying to essentially get the statement list section. So that's state, what am I doing here? Path. And luckily we've already done a lot of this work before. So we have elf metadata dot dwarf info dot sections, and the sections of debug line, I think, is where it's supposed to go. And it is the data here. So now we should have the line program at debug line 0. So let's look at printing any debug line. I guess we should look at debug line from statement list offsets onwards, which just happens to be 0, but doesn't necessarily have to be 0. Expected use size found something else. So int from enum. And then this should be dwarf stud dwarf section or something. How did this work? Fuck. This gets a dwarf section from stud dwarf, yeah. So this should compile. Elves and dwarves, how wonderful. We love them. We love the elves and the dwarves. Okay, there we go. So we got the thing printed, and now let's just actually get into the work of extract location instructions. So let's try to parse this thing in any way. What a fucking long detour, but that's okay. We will survive. So where was this? This was in section 6.2. Line number information. We should just start looking at the format of this thing, and we should be able to move from there. So, okay, we expect to see an initial length field here. So from what we were seeing before, the initial length field is this like fucked up FFFFFF0 thing. And then I remember also it being different between 64 and here we go. So the following 8 bytes contain the actual length represented as an 8-byte integer. In 32-bit dwarf format, the initial length field is an unsigned 4-byte integer, which must be less than this. In the 64-bit dwarf format, initial length field is 12 bytes in size and has 2 bytes. The first 4 bytes of the values FFFFFFF, and the following 8 bytes contain the actual length. So if we are trying to extract this thing, this should look at debug line from statement list offset on. So we should actually look at program is equal to debug line statement list offs onwards. And then we can look at prog 0 to 12. This should give us something interesting. What I expect to see here is the first 4 bytes of 0xFFFFFF, and then the following 8 bytes being a reasonable thing. So let's just double check. If that's true, then I think that we are on the right track to know that we're looking at the right spot. Instead, we just see a lot of like leaky logs, which is fucking annoying. So let's at the very least do this to try to reduce some of those. Okay, so that is not what we see, which is not a good sign. That's actually a very bad sign because it means we're not looking at anything that we understand. Right? Because he is saying, the spec says that the line number program for each compilation unit begins the header containing the following fields in order. And that's like the first thing that I think we've seen. I wonder if there is a section header thing that we are supposed to parse that is not that. Line number program for each compilation unit begins the header containing the following fields in order. And this is very much not an initial length because oh wait. In initial field, the values of these are reserved by dwarf to indicate some form of extension relative to dwarf version 2. Such values are not to be interpreted as a length field. The use of these is defined, but it's not one of those, so maybe that's okay. The initial length field is one of the fields that occur at the beginning of those dwarf sections that have header, or the length field that occurs blah, 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 blah. So is it kind of saying that like, are they kind of saying that it can just be a raw length? 1, 2, 3, 4, 5, 6, 7, 8. Feels like a big number. Feels pretty large. Could be, did we like accidentally like freeze some memory that we weren't supposed to? It's possible. Get elf metadata. He allocates error defer free section data here, comes in, and he's only error defer freed, so he shouldn't be gone at this point. Cause yeah, I don't see any reason why that would have happened. Unless DI error defer, he's only DNA'd on error defer, so I think it should be fine. I think it should be fine. Very interesting. Why is everything so hard? Why is everything so hard? Initial length. Where do we get here from? We like clicked on something. Initial length. An initial length. Okay, that's that. If we click on this, does it take the same place? Yeah, they both take the same place. An initial length field is one of the fields that occur at the beginning of those dwarf sections, blah, blah, blah. Okay, yeah. Or the length field that occurs at the beginning of a CIA FTT structure. Okay, in initial length field values, these things are reserved by dwarf to indicate some sort of extension. Such values are not to be interpreted. The use of other values is reserved. Oh, so yeah, if we're not seeing one of these two things, then it's a fucking bug. And we're not seeing one of those two things, so it's a fucking bug. Which is super cool. Super cool. Yeah, so there's a possibility. Can we maybe print like the first like 100 bytes of these things? And can we do like, how do you make sure that these things are always 2 digits versus 02? So oddly, I don't see anything that looks like a 0x FFFFFFFF, to be honest. Which is surprising. Very, very surprising. Can we do read elf the debugger, and can we like try to find this debug line section? So this is supposed to be offset at 3EE7B, I believe. I believe that's what this means. So can we like hex dump -c zig out bin debuggy, and then look for like 3EE03E7. So in this data, I don't see that at all. Can we look for maybe like FF, 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 FF? Yeah, I mean, it's not looking too promising. It's very possible that I forgot what these offsets are. So this is name. Oh, that was size. Oops, I was supposed to look at offset, which is on the right side. So that's a good clue. Well, clue is strong, but so debug line. We're actually looking at this, I assume. 1C. Here, we'll find this. Hello? 1C DC 0D. 1C DC 0D. So this does not, like, so this stuff all being string table stuff makes me think that we were probably looking at the wrong. Did I get my offset wrong? Debug line. Looks pretty confidently there. 0, 0, 1C, DC, 0D for this long. And this is looking at zig, out, bin, debugging it. But if we hex dump that thing, I mean, this is pretty clearly a bunch of strings, which does not make sense with what we are seeing there. So either the segment is like zeroed out or something, but that can't be true because in readelf, he says that the length is actually quite long. Name, type, address, offset. Oh, maybe this is where it's supposed to be loaded, not where it is in the data. That's very possible. Can we look at when we do our elf parsing? When we do our elf parsing, we have section headers to look at. And can we look at what these things are? So sh adder and sh offset. I'm pretty sure that we've been looking at sh offset. We are. Can we std debug print section name s and offset, and then print this in hex. And sh dot, we want this to be section name and the offset to be shdr sh offset. Section name, debug info, offset, this value. Am I fucking high? We get name, type, address, offset, size. So debug line, we don't see this number anywhere. Oh wait, we did. 1C, DC, 0D. We did see that. I'm just high. I was looking at like this for some reason. Yeah, then I'm confused. 1C, DC, 0D. It just doesn't line up with what we see when we hex dump this thing. Right? It just does not line up. One, because we are not seeing the values that we see in the spec. Two, because it's a bunch of strings, which doesn't make sense. Right? Can we look at like 1C, DC, 2 something? Is that something in this table? No. Very interesting. Very interesting indeed. Maybe we need to look a little bit closer for debug line in here. Okay. This information is placed in a separate object file section from the debug information entries itself. The value of statement list attribute is the offset in the debug line section of the first byte of the line number information for this compilation unit. Right, okay. That's what we expected. Whoa. In an object file with a conventional compilation unit entry, the type unit entries may refer to a share the line number table used by the compilation unit. In a type unit located in a split compilation unit, something something debug line DWO. I don't think we have debug line .dwo. We only have debug line. Okay, we're going to keep looking. Debug line. Line number information is represented in the debug line section of the object file. See this full and partial compilation unit entries, so we've already read that. If space were not a consideration, blah, blah, blah. Okay, so just tell me, like, what is it supposed to be? You know? Oh, wait, hold on. This is needed to support common practice of stripping all but the line number sections. Oh, so prior to DWARF version 5, the current directory was not represented in the directories field, and a directory index of 0 implicitly blah blah blah. In DWARF version 5, the current directory is explicitly present in the directories field. This is needed. Oh, okay, so that kind of makes sense. So if directories for debugging info, do we have debug line stir in here? That's a clue. That's a clue. So there, the debug line section is like embedding directory names maybe directly, and so maybe that's totally okay because there is no debug line stir. So can we look at debug line stir? Okay, wait. This is maybe reasonable. So I still don't understand why we are not seeing this, but maybe we are seeing like the start of the program. Can we look at like, if we were to see something that looked like DWLC path, the component is an alternate path name string. If the associated form code is form string, then the string of code immediately containing directories or file names. So maybe we should check if the thing is prefixed with DWLCNT path. Because if it is, so if all of those directories are prefixed with like an 01 or something, then maybe that actually does make sense. Maybe. Maybe not, but maybe. We need to try to build some knowledge. So 1C DC00. 1C DC00. So here, if this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the 10th character in. So this is 8, 9, 10. So this is prefixed with an 01. And these do look like null terminated, I think. Null terminated directory entries. So I wonder, that doesn't really explain why we are not seeing the program header. But at the very least, we could maybe imagine that this isn't immediately crazy. So where's D? FED. So this starts at 5.1. I wonder if we can look for opcodes here and just see if this happens to line up with an opcode. Not really. The first thing we see is 5.1, which is nothing. Really. I would like to see if we can find this initial length thing in other tables, because it's bothering me that we can't find it. So like, can we look for like debug A ranges? Does that have the same problem? Debug ranges. I guess we could be in the wrong spec. How do we know what version of DWARF we're using? That's another good question we should find out. How do we determine? How do we determine? Can we run with like -W here and run into less? Version 1? I would actually look for LNS in here. It is possible. How do I know? Read elf get dwarf version. Compilation unit. Here we go. Okay. Version 4. Okay, so let's look at the version 4 spec just in case, because that's kind of a red flag to some extent. Can we look at the DWARF 4 spec? And oh, is there no table of contents? Oh, there is. Okay, so everything is different. Everything's different. Got it. Got it. It's all different. So can we look for does this not even have the line program thing? Because that would make me so sad. Okay, line number information. C6.2. Okay, this looks very similar. So we can just go back here and look at the line number header. He's saying the same thing. Version 4 is saying that we should see this still. And that's confusing that we're not. Is there anything in here that like we can use as like a sentinel value or something? Include directories. Entries in the sequence describe each path that was used, included for source files in this compilation. The last entry is followed by a single null byte. Oh, so maybe this is just the include directories section that we were seeing there. Can we do tail? I think it's tail, and then you do like get print get offset bytes tail. There's a way for you to say like here, output the last bytes, or use -c to output starting with byte num of each file. This is what I'm for. So we can do read elf -e to give us these offsets. I want to take this offset, turn it into an integer. And then I think it's like tail-c plus this number. Skip that many. Zig out bin debuggy hex dump -c less. I think we said the 5-1 was supposed to be the first one, so I went off by one the other direction. There we go. So there is a potentially this set of here could be the include directories field, which is supposed to be followed with the last element is got another null byte after. What is the 12th thing? File names, entries in this thing. And so he's got built-in.zig. Okay, wait, okay. Linux zig. Here are all of our file names, maybe? Do we have debuggy.zig in here? I don't see that. Surprisingly. Okay. Hey, hope you're having a good day. Hey, man. You too. So I'm mostly just stuck on this. Initial length values, like the use of the initial values. Oh, this through that are reserved by dwarf. Sure. The other values in the reserved section is not good. So does that mean that if it's not those, then it's just a raw length? Okay, wait, maybe. And this is the number, the size in bytes of the line information for this compilation unit, not including the unit length field itself. So if we were to look at this value as a little Indian, is it 8 bytes? I forget, sorry. Fuck. Fuck, fuck, fuck. An initial length field is an unsigned 32-bit integer which must be less than this. It is 96 bits in size and has 2 parts. The first 32 bits must have the value of this. It feels like there's a chance that we're using a 32-bit format, but maybe only for this section? Is that possible? In which case we would see a length of this. Okay, let's see. So Little Indian means that it's 0002BB51. 0x02BB51 is this length plus 4 for the total length. 179029. Does that line up with the length field here? Is that what this is? Size. 3EE7B. What did we see? Something less than that, but there's two compilation unit things. So we can actually check. Hold on. I understand a little bit now, I think. We can go back into debug info and we can check what the offset is of the second translation unit. Because there's only 2 translation units in our thing. So if we skip one, then get the address of the next, we can print that address. So let's go std debug print tu has line offs this value. Okay. All right. So I don't see him printing that anywhere, which is very confusing. Oh, it should be actually up here. Tu has offset 2BB55. Hold on. 2BB51 plus 4 is 2BB55. We fucking figured out one field. Let's fucking go. Let's go. So at some point we started looking at like interpret line program header. So this means that we are using 32-bit dwarf format for this section, which is actually really confusing because as far as I understand, we've been using 64-bit dwarf version everywhere else. So that's that satisfies some amount of confusion. Okay. So we should be able to say that we have I guess we kind of want to do something like make a reader that's like a buffer reader, fixed FBR fixed buffer reader is going to be like std.io fixed buffer stream around prog, and this will let us do stuff like say reader read bytes read all maybe, yeah, and then we can read all into like std mem as bytes of a U32, right? So we can call this like, where were we? Here, compilation unit header. So maybe we even want to just go and say like, wait, is this where we were? No. Line number program header. Line number program header raw is going to be a packed struct, okay? And for now, he's just going to have the unit length as a U32. Now, in the future, this won't work, but we are going, like, if we were trying to handle anything, like 32 or 64-bit types, this won't work, but we'll kind of just say, maybe we'll throw a 32 in here so that we know. And I guess this actually still wouldn't work if the value was FFFFF. So I guess we actually need to parse it as we go. So maybe we do something like, we don't do this raw thing. I was going to like feed this directly into the reader, but now I think that doesn't make sense. Instead, we'll do init with a reader. And then we will do this. Okay. So we do like const unit length is a u32. We shove that thing in here. Okay. And then what? Return unit length is equal to unit length. Okay. So now we can do something that's like line program number header 32 initialized with reader. And then we try this, const header is equal to this, and then we print the header. So any, and the header. He's mad because, oh right, because it like might not be aligned, this unit length field. So reading it like this is actually not really valid, which is kind of fucked up. No wait, it is, right? Value bytes as value, bytes to value. So I guess we do for u8 like this. And then do std mem bytes at to value u32 unit length. Okay, I think that should do it. There. He's mad because this should equal undefined. Okay. He's actually still mad because I wrote const here. That makes sense. And value of size ignored. Yep. I did want to ignore that. And now we should see a... Oops. Here I want to go back to the correct first compilation unit. And we see unit length 179025, which I think is chilling. I think that's chilling. Okay. So here we were gonna do just like assert that unit length is less than 0x ff f0, right? Because that was the max length. And then we keep going. Does the reader have like a API to be like, read me into this thing? No, it doesn't. Okay. So now we are going to just try to extract some of this information. Version and header length. So version, I kind of want to do something that's like a read type given a reader and a like t, right? I kind of want to do this. And I kind of want to just kind of like bundle all of this up into one thing. So this is going to be like size of t. Then we return t like this and return like this. Read int exists. Yeah, I guess that's basically what I want, huh? I guess that is kind of what I want. Reader read int u32 unit length buff. Oops, sorry. Like this, probably read int. Little Indian. Yeah, sure. That feels more sane to me. Let's just make sure that it's still right. Yep. Cool, that's much better. Okay. So then we read version is a... In fact, we can probably do this all inline now. No, we can't. We can't. Version is a u half, which I believe is defined as a U16 here. UHAF is 2-byte integer. Yeah, so U16. Where were we? Fuck me. Here we go. Version UHAF header length is the number of bytes following the header length field to the beginning of the first byte of the line number program itself. In 32-bit format, this is a 4-byte unsigned length. U32. So here, I guess the rest of these guys can't go here though. So version is equal to this. Header length is equal to, this is U16, this is U32, cool. Minimum instruction length is a U byte. Maximum operations per instruction is a U byte. All right. Default is statement. We'll figure out what these things mean later, but for now, we'll just kind of try to populate this whole thing just to see if it makes sense. Maybe we'll start with these. So can we do something like paste these here and then put a dot, do this is equals to try reader dot read int little Indian. All right, let's just see what that gives us. Version 4, good sign, I think. Header length, this. Minimum instruction length, 1. Maximum operations per instruction, 1. Default is statement, 1. Opcode base, 251. I mean, none of these seem like, who knows, right? This is kind of hard to know, but we will see. Standard opcode lengths. Array specifies the number of LEB 120 operands. Wait. Oh yeah, this is the first array of stuff here. So I guess what we should do is we should finish parsing this header and then see if it matches up with the header length. Okay. Standard opcode lengths is array. So this array is a bunch of LEB 128 operands for each of the standard opcodes. Whoa. The first element of the array corresponds to the opcode whose value is 1. The last corresponds to the opcode whose value is opcode base minus 1. So by increasing opcode base and adding elements to this array, new standard opcodes can be added while allowing consumers who do not know about these new opcodes to be able to skip them. How can you skip them if you don't know? Like, okay, sure. I guess you just have to make them like they were to be skipped. So I guess that kind of means that this concept of doing these all inline here is actually a no-go, which is fine. Here this goes like this. All right. All right. And then I guess we kind of do like, I guess we probably don't need to return all these things directly, but for now I think we will, because it makes things easier to inspect for debugging. Oops, all of these guys wrote version on the other side like a dumbass. But we'll fix that. Max default is statement and then opcode base. Okay. Now here we're starting to get a little crazy. So this gives me a bunch of LEB 128. So we can say like for 1 to opcode base minus 1. I don't know if we care necessarily about the size here. We are going to read 1 LEB 128. So there should be read LEB 128 like this into, I'm going to read them into U64, so I'm not really sure, given our reader. And then here we will say var opcode lengths is equal to an array list of U64s initialized with an allocator. I guess. Which means that this guy needs to be called with an allocator. We will defer standard opcode lengths d init, and then do the standard thing of being like opcode lengths here is not an array list, but just a bunch of U64s. Opcode lengths is equal to own slice. There we go. Okay. All right. So hopefully this works. Value type U64 is ignored, so this has to be standard opcode lengths dot append val. There we go. So all of our opcode lengths, some of these being like 114 bytes long, seem suspect to me, but I'm not willing to count it out just yet, right? Because this is what they said, right? The first element of the array corresponds to the opcode value who is 1, and the last element corresponds to the opcode value who is opcode base minus 1. Well, I guess it... Yeah, I think you would have to just do every single element in between. So we could see if we check this manually. I guess we'll see in a second. If we just do like include directories should immediately get strings, right? Entries in this sequence describe each path that was searched for included source files in this compilation. Each path entry is either full path name or is relative to the current directory of compilation. The last entry is followed by null byte. The line number program assigns the numbers to each file entries in order, beginning with 1. The current directory of compilation is understood to be the 0th entry and is not explicitly represented. Okay. So can we look up like path name? Like, how is a path name represented? I'm going to assume that it's just kind of like inline here, which makes it seem like we should immediately get like a /nix if we start looking at the reader right now. So we did like stud leb, no, sorry, reader read all, and we just tried to read like buff is going to be like 50 U8s or something, right? And we just like read into this buffer right now, and then stud debug print the buffer. I think we should see like an include directory if we've done everything up to this point correctly, which we probably haven't. We never do. But we can dream. Yeah, so this makes it look like we've kind of fucked up. And then I'm looking at this and I'm kind of thinking like, surely this starts here, right? Which makes me think that this is wrong, right? This header length feels like it starts, so we have to unfortunately, this is like the pain of this type of shit. Is like you have to go back and try again. So we have initial length, we are pretty confident on U32. Version, you have U16. Okay, header length. This is a 4-byte unsigned length. Okay. So we did do 4 bytes. Minimum instruction length is U byte, U byte, U byte. So U8, U8, U8. Opcode, oh, we missed some. We just skipped 2, line base and line range. Line base, line range, and these were supposed to be, line base was an S byte, and line range is a U byte. So here we have line base and line range. And we just kind of propagate these guys onwards. And line range, line range. Sorry, what was it called? Line base. Hello, 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 hello. What's up? All right, let's try this again. So now we do see that this thing starts immediately with a /nix store, which is really good. And the opcode lengths also look pretty reasonable to me. Looks pretty reasonable to me. So the include directories are supposed to be just a bunch of null separated things until we see a double null. So we're gonna do something like while true. Is there like a read until? There is. Nice. And then this thing will return stream too long or not EOF. Stream till. So we probably want the alloc version. It's probably easier. Read till delimiter alloc. Allocator. And then we want the delimiter, which is just going to be a null byte. And then max size will say like, something reasonably large. So here we'll say const p is equal to this, and if p len is equal to 0, then we break. I think that is reasonable. And then here, all we have to do is push into an array list of strings. So this is the include directories like this, and we have include directories here. Unfortunately, we have to do all this parsing because if we don't, then we won't know where the program starts, I assume. I guess we could have just gone up to header length and then jumped on, but I'm also assuming that this stuff will be relevant in some way. But maybe we're wasting our time, but that's okay. Include directories equal to try. Include directories to own slice. All right. All right. So if we did this right, we should see a bunch of directories pop out here. Instead we see nothing. A little surprising, to be honest. Probably because we didn't actually do anything with this. Right, we forgot to push those things into our buffer. But if we do push them into our buffer, we see a bunch of stuff, but they're not really legible. So can we do like for header include directories p stud debug print a string of p. Let's try that. Shut the fuck up, general purpose allocator. Okay, that leaks. That works. Pretty promising. S works on slices strings too. Oh, that's kind of nice. So you're saying I can do like a header include directories like this. I'm just going to go into dwarf test for now and just kind of disable GPA deinit so that we can just ignore leaks and then they're not problems anymore. Yeah, that's a lot nicer. Thank you. Okay. So now what? We have more to parse. More to parse. File names. In this you can describe blah blah blah. Each entry consists of the following values. A null terminated string containing the full or relative path name of the source file. If the entry contains a file name or relative path name, the file is located either relative to the compilation directory, blah blah blah, an unsigned LEB128 number representing the directory index of a directory in the include directories section. An unsigned. Is it all of these? Yes, of all of them. An unsigned LEB128 number representing the time of last modification and representing the length of bytes in the file. Last entry is followed by a single null byte. Okay. Right, so here, I guess that means that we're going to have some sort of like file name, right? And he's going to have all of these things. The name and the dir index, right? The m time, and I guess dir index was also U64, and a unsigned length of bytes, right? Now this thing is going to take in the reader, and I guess almost certainly an allocator as well. And he is going to basically do something that's very similar to this loop, I think. It's going to be files. Oops. Oh, sorry. This is, we're only trying to parse one file here. So here we're going to be like, yo, did we fucking get this thing? And we're just going to be like, yo, read until we see a delimiter. And if here we actually probably only wanted to include append the thing if it wasn't length 0. So here we're going to return null, right? But if we don't return null, then we can read 3 LEB128s. So it's just dir idx, mtime, and size. Right? And then if we get through all of that, we can return the name is equal to p dir index is dir index. I guess kind of for these things, we actually can put them inline here, which is a big win for us because that means less typing. Like this. All right, so now we kind of do this loop externally, but this becomes file name, or files, I guess. I guess we could call them file names. This goes file names, but just instead of this, we say file name dot init with an alloc and a reader. We try it, and if it succeeds, if it fails, we break, we're done. But otherwise, we append it. And then we should be able to be like, yo, file names is a bunch of file name. Wow. Wow, wow, wow. All right. Let's see. Oh, I guess we're not logging this thing anymore. He doesn't like this because we can't do S on slices like that. Unfortunately, but we can take a little look. So who knows? Who knows? It looks pretty sane to me. Can we like for header file names? I guess FN is wrong. We print S as F name. Looks reasonable to me. Those sure look like real names. Well, some of these don't. WY hash, I guess maybe that is a real thing. Now, what's kind of weird to me... Oh, debuggy is in here. It'd be kind of interesting to print the directory names and the directory index as well. Because we should probably see that the directory index of our debuggy is different than all the others. So I think that was here. Debuggy is index 0, and I think that is the only thing with index 0. Which makes sense, because it's the only thing in our source file. Okay. Cool. Cool. And we're done reading the header. Thank God. We finished reading the header, and I was kind of planning to be kind of where we are now 2 hours ago. That was my like initial plan. And given that we are not where I wanted to be 2 hours ago when the stream started, I kind of feel like this is like a good kind of opportunity to end. Because I wanted to give myself like 3 hours to do like a real virtual machine implementation or whatever. Clearly that didn't happen. But yeah, I would like to, if I start that now, this is going to be too long of a stream for me. So I think we call it there, and we come back and we do what we thought we were going to do today, tomorrow. Yeah, I think that's reasonable. Apologies for the bait and switch on the Twitch title. That was not intentional. It just is because it's we took too long on something that I thought would be simple. Plans were wrong again. Yeah, classic. You know that thing where programmers like, I can do anything very fast. Like, give me a day and I'll do that. And it's like 2 months later, you're like, so are you done? You're like, well, long day. So, thanks for watching, guys. I hope that this was still entertaining in some way, shape, or form. I understand that like maybe just copy pasting header field is not the best, but you know, this is the way programming goes sometimes, where you're just like, I have a spec to implement and I fucked up reading the spec like 4 times and I fucked up implementing like 4 times, and it's just slow, and that's okay. Thank you for watching. If you like what you saw, we stream most days at around, well, okay, so lots of days around 12:30 Pacific times, other days around 2 o'clock Pacific times. It depends on if we're going to do a happy hour or not, where happy hour is kind of like supplemental content. This could have been a happy hour. If I had known that it was going to take this long, I would have done it that way, because this isn't really particularly interesting, but I try to keep it so that like 2 to 4 segment is like things that are going to go into YouTube videos and are, I think, interesting new features that are worth a video. This I would not have put in that category, but it will be because we're here now. But if you want to come by at 12:30, you might see stuff like this, but maybe a little bit more laid back with some music and stuff. If you come by around 2, you will see your typical YouTube stream. If you are on Twitch and you haven't seen the YouTube, there's a YouTube link in the Twitch description. There are playlists for all of our projects. We are currently working on writing a debugger, but there's other stuff in there if you want to check it out. There's stuff like writing an operating system, neural network, making a terminal emulator, video editor, maps. People liked all of those. QR code decoder I kind of was particularly fond of. So if you want to check those out, there's a GitHub link in the Twitch description as well, where code for this project will show up under the DSphero project. If you are watching on YouTube, there should be a Twitch link in the YouTube description, and you can swing by and say hi if you're online between 12:30 and 4 Pacific time. Otherwise, goodbye YouTube and Twitch. Let's find someone to raid.